Yep. Hello, everyone. In this session, we will essentially go through what are all the services and tools that are out there for specifically for generative AI, which various companies are providing, and like how they apply for various purposes, and how do we use them if you want to. So just to start with, we have like a very brief sort of timeline of how this AI thing has happened up until now. So essentially, there are these smaller pieces. So the very first thing that happened in this context was the classical machine learning stuff, which included things like just wait a minute, let me maximize this screen. Yep. First of all, we have the classical ML, which have things like linear regression, decision trees, clustering, k-means clustering, k-nearest neighbors, those sort of algorithms, which are essentially just statistical methods at core, but which were being used for several applications, whether it be in business or medical or pharma, that sort of thing. So that's the first thing. Then we had the so-called deep learning methods. In this thing, we had the advent of the multi-layer perceptron and convolutional neural network, deep convolutional neural network. Those sort of things happened, and from deep learning itself, the applications broadened quite a lot. So like we have started to have like the computer vision, natural language processing, that sort of thing. Then the very latest stuff is the large language models, which are essentially text only models, but these are, if we compare the computational expense that these generations take, so classical ML is actually extremely efficient with respect to computational complexity. Deep learning is more complex than classical, and LLMs are extremely more computationally expensive than the previous two. And then the very latest thing is the multimodal models, which actually only very few of the bigger players are working on as of now, but we will get into it later in detail. So this is sort of the timeline for the overview of this thing. And now we move to how essentially any AI based product has its lifetime. So this is what's called as the workflow. There is this thing that AI and ML were used interchangeably and loosely in the earlier stages. So that's why everyone refers to this thing as ML ops. But in general, this actually applies to all the AI applications, not necessarily just for ML. So it essentially revolves around, first step is always the data thing, the preparation and processing of data. But obviously, after that, we have the model training or selection of models, what model we are going for, and then the evaluation part. So these three parts are actually what constitute most of the research work that's there. But from the model deployment and serving side of things, we get to the nitty-gritty details of where do we deploy the thing, how secure is our deployment, and how do we scale it up for large number of users. So that sort of thing starts to get into a picture from here on. And obviously the monitoring is always necessary, because it doesn't matter how well we did the initial training and research part. It always happens that in real-time deployment there are some bugs, errors, unexpected behavior from the model. So that's why a continuous monitoring of model is also required. So this essentially constitutes the overall lifetime of any AI-based product. So, as we can see, like from for the deployment side of things, there is a necessity for the cloud thing, for us to get a use of the cloud thing, because hosting, deploying, serving, and essentially looking after the security aspects of the our product, of our AI product, is quite tedious if you want to manage it all by ourselves. So that's why, especially for this part of the this side of the thing, businesses generally prefer cloud-based solutions, regardless of where the actual research happened. Yep. So that was just an overview of how these AI products live and how they are built.
One, Zishan, one quick question. The on the multi-model models,
Yes.
I think it's what is that? Can you just tell?
Yep. So essentially, modality just refers to the types of input in this context of AI. So modality refers to different types of input. So one type of input can be textual data. So these are all textual data. One input can be images. So these are all images. So these are two different modalities of data. One can be speech signals. So that's a third modality. So what multimodal models are is that they are capable, they have been trained and they have provisions for handling different modalities of data all at once.
Okay, understood. Okay. So are they necessarily larger than the large language models, or
Yes.
sort of?
Yep. So actually, there are several ways using which these are built. So one of the popular ones is that so they have let's say there is a vision-based model which is really good for vision-based tasks. So let's say we have one CV model which is really good at segmenting objects. It can detect objects really well. We also have a base so-called foundational model, the large language model. So one of the ways that people have been trying to just stitch together a multimodal model is that they will just fine tune both. They will just try to stitch these together, the CV model and the LLM, and try to fine tune it at some stages and get together to a like combined model which has both the capacities.
Okay, sounds good. Yeah.
Yeah, but obviously, because like it has to process the other modalities as well, it has to be larger than if it just had the language model at its core. So we move to the enterprise tools. So first one is the Google. So obviously, given the scale at which Google operates, they have they do provide a whole. Actually, they have their tentacles spread all across the product line in the AI landscape. So first one is the Google Cloud's own AI platform. So this is the ML workflow according to Google. So if you have a look at it, essentially the same thing as what we had earlier. Uh, but it just tells they are just trying to tell us that the Google Cloud's AI platform has capability for us to do all of these in just a single place. So they actually provide a whole lot of features. So there is something called Auto ML, which provides us with pre-built vision models, language models, that sort of thing, which do not require any coding from our side. So those can be used. They also provide us with the capacity to like have bring in our own model and train it on their platform, because we can use the computing resources that they are providing. Then there is also that option that we have the completely trained model from our side and we just bring it for deployment aspects. So almost all sort of things can be implemented on Google Cloud's AI platform. But there is one thing, this was the older version, which was primarily used for the machine learning side of things, or at max the deep learning, not necessarily the LLM based thing. So because of this, as Google is also shifting its focus towards the LLM and larger models, they are shifting lots of functionalities of Google Cloud's original AI platforms functionalities towards a new platform which they call the Vertex AI. So the next thing is the Vertex AI only. So this is essentially an overview for ML ops that Vertex AI provides. So it actually provides us with all the functionality that we would need for a complete ML lifecycle, from data pre-processing and preparation of data, feature engineering, and all these sort of things. The Auto ML provides us with pre-built models, which with which we don't need to tinker a whole lot. We can tinker them, but we can use them out of box as well. So this is for the classical or at, let's say till the deep learning side of things. But as far as the large language model based applications are concerned, Vertex AI has something called a model garden, which has not just Google's LLMs, but it has several open source models hosted there as well. So Yeah, obviously one of the key issues with having an LLM is that even if, let's say, there is some open source LLM which performs really well for our task, we found this in our test. We don't necessarily know how are we going to implement, or let's say run this model on our own system, because obviously these models contain, at least by definition, billions of parameters. So if we want to have a product based on this LLM, which let's say we are expecting a few thousand users to use simultaneously, so we would need huge amount of computational resources, which is very difficult to have in-house for a small to medium enterprise. So that's why, like, on Vertex AI, there are several of these popular open source LLMs hosted there as well, and we can just use them if you want to. And yep, that's there. Obviously, Google's own LLMs are also accessible there. Uh, and yeah, the core functionality, the standard functionalities like building RAG applications or fine tuning a model for particular use case, those are also provided at Vertex AI. So another key benefits is
So
that
one quick thing.
yes,
I'm not so sure if you had mentioned it here. So, for example, do you have access to Hugging Face models from here, from Vertex
yes,
AI?
yes. Yes, so in this 130 plus models, there are several models from Hugging Face only. So on Hugging Face, the models are not necessarily hosted, and obviously the weights are there on Hugging Face, but they are not necessarily hosted there. So if we want to actually build an application which wherein that LLM is actually running all the times, then we can just fetch that model from Hugging Face to this place and deploy it here.
Okay, got it. And does that sort of update as the model updates, for example, there? So does it update or how does that work?
Yes, so if we so the best case would be to search for if it is already there in the model garden, the model that we are
Okay,
looking. If it's there in the model garden of Vertex AI, then they will take care of that thing, as per Google's service. But
got it.
if
Okay.
we are bringing it on our own, then we will have to keep looking out for it.
Okay. Okay. Anyway, so there is certain integration, and maybe whether it updates or not on an automatic
Yes.
basis, I think they can give an option or something like that. Eh?
Yes.
Okay. So I think, see, one of the key issues that let's say we as users face, right, is that let's say if you get attached to one of the platforms, right? So for example, these days, right, so on mobile you have like two platforms at this point largely, right? One is the Android based platform, and the other one is the Apple based platform, right? So there were also others like Microsoft's and all, but they withered away. They don't no longer, sort of are strong, right? Because if you want users, you have to use one of these two. So but from our standpoint, we don't want to get locked in to one of them, right? So one
Yes.
of the key things that is available, which is vibrant at this point, like we saw in that IBM video, right, is also the open source platforms, right? And a platform, if you look at it, in fact, I was chatting with, I think I mentioned to you guys some time ago, I was chatting with one person who is part of Google's sort of platform, sort of you can say loosely say he's an account manager of sorts. Okay, so this guy goes to companies and tells them what all it can do and things like that. All right, and he would have training resources available for them, right? Understand their use cases, figure out if there are any issues, sort them out, things like that. So essentially, sort of paving the way for customers to utilize their services. So one of the things he was saying was, you choose one platform, okay, because it serves their purpose. That's a different matter, but that's what the companies like that tends to do, right? So that they want to promote their own platform and use their platform more and more. But the if you want to dilute that, we would obviously say, hey, I want to use some other model which is not on your platform. Can I use it? Right? So it is sort of cross operability, right? If it is Google to, let's say, AWS, that's a different matter. They would typically not want to do that, right? Because, if you lock in, that's why they're calling it a garden. There is a term called a walled garden, right? Walled garden means basically, you wall it. Within it, there is a garden. But if you go out of it, the garden is no longer, you don't get the fragrance anymore, right? Or you cannot see those flowers. So that is how it works. So, but here the interoperability with Hugging Face and other models is very interesting, because all of them may, instead of keep working with the open source one, which means that, on one hand, each of these models, each of these platforms will grow. At the same time, all of them will help, a platform like Hugging Face grow, right? Which is good for us. But, I mean, we'll have to look at the interoperability piece later. Yeah, please continue, Isha.
Yep. So that is there. It does allow us to bring in our own LLMs, but the mostly the open source ones. If let's say we are trying to bring in OpenAI's GPT, that I don't think that's possible within Vertex AI. Yep.
Okay. So as of now, OpenAI, they are not helping. So basically, now you have to use an API or something to be able to do it, is it? And write our own code and stuff like that, right? Is that right?
Yes. Yes.
Okay.
Yep. So obviously the standard benefits are also there. The connections would be secure. The API endpoint that would be created using this platform would be secure. And that sort of thing would be there. Obviously, the very important aspect that's there, which is the monitoring and logging of all the use cases or the inferences that we run, that also happens quite systematically here. Uh, Yep, so that's it. And obviously it goes beyond LLMs. So as they have shown itself, like the basic machine learning and the deep learning are also supported for both like the auto ML or purely custom models. Another thing which is important for us is that LangChain integration are supported for the Vertex AI APIs. So we can call the models using LangChain in our own Python environment if you want to. Yep. So this is not a platform. This is just a generic product called Bard from Google. So we have all used ChatGPT from OpenAI, which is just a chat interface, wherein we are conversing with the one of the GPT models. Specifically, if we haven't paid for it, then we are using the GPT 3.5 Turbo model. So similarly, Google has its own assistant chat platform. It's called Bard. So this is the interface of Bard. Uh, and yep, so essentially this has lot of integrations built into it. So it uses Google's search for producing answer. It can fetch us back results with reference images, that sort of thing. Uh, Yep. So essentially, the Bard which I was using had a lot more functionalities than the free version of ChatGPT, which only generates the answer based on GPT 3.5 Turbo's understanding of whatever is being asked. This Bard can do Google searches as well, and can fetch images or links as well, which are working. One of the uh, issues with ChatGPT is that it always produces hallucinated links which end up going nowhere. So this is about Bard platform. So this is not this doesn't have much to do with implementation. So there is not much here. Uh,
Sorry, what's with the links you mentioned in ChatGPT?
yep. So if you try to let's say you ask it to bring in some papers, or let's say you want you tell it, okay, I am searching for this. Suggest me a few products. So if at all it produces links for those products, which it thinks will redirect you to the page of, let's say, Amazon page of that product, it will take you to somewhere in Amazon, but that link would be broken. So that would be a 404 error type page. So ChatGPT is known for doing that one, producing
Oh, okay.
incorrect.
Yeah, I think in any case, I think the ChatGPT results are based on dated data, right? So by the time they give us the links, I think it's probably already outdated or something. Yeah.
Yes, and
Okay,
another
got it.
thing is the RAG aspect. Like this Bard is actively doing RAG. Okay, मतलब it uses the Google search results as the basis of its knowledge for particular cases, not for all cases. So that's why it's more knowledge grounded. Like it's less likely to hallucinate because it has actually done the search and it's produced the results based on the result of search.